Hello everyone, welcome back to my Python Complete course. In previous lecture, we learned about input and output in Python, that is file handling, and in today's lecture, we are going to talk about object-oriented programming. Oops, okay. So let's begin this. Okay. So if you have searched for Python jobs or watched of advanced Python tutorials, you have probably heard terms like class, object, constructor, and methods. Don't worry if these words sound confusing. By the end of this lecture, you will understand them step by step with practical analysis. Or let's get started. So first question is, what is OOP? Okay. So before learning the definition, let's observe the real world. So look around you. You can see things like a laptop, a mobile phone, a car, student, and a teacher. Okay. So these are all objects. Every object has two things, that is data and action. Data is also called properties and actions is also called behavior. So for example, consider a mobile phone. Its data includes brand, RAM, storage and battery. And its action include calling, taking photos, playing music and browsing the internet. So similarly in programming, we create objects that stores data and perform actions. That idea is called object-oriented programming. So why do we need object-oriented programming? Imagine you are building software for a school. There are 500 students. Without OOP, you might create hundreds of separate variables. The code quickly becomes difficult to manage. Okay, so with OOP, you define one student blueprint and create as many student objects as needed. So this makes your code reusable, organized, easy to understand, and easier to maintain. So that's why most modern applications use OOP. So what is a class? So a class is a blueprint or template. So think about an apartment building. Okay. So the architectural design is created only once. Using that design, many apartments are built. So the design is in the class. Is the class. Each apartment is an object. So similarly, a class defines what object should be look like. Okay. So creating our first class. So we are going to create our first class. Okay. So once again, class student, then pass. So let's understand this. That is, class is the keyword used to create a class. So student is the class name and pass means the class is empty for now. So if I run this program, so nothing happens. But why? Because we have only created a blueprint. We haven't created any object yet. So next we have, what is an object? So an object is a real instance of class. The object is the actual thing created from that blueprint. Okay. So without objects, a class doesn't do any work. Okay. So we have to create our first object, class student pass, then s1 is equal to student. Okay. So here student creates an object and s1 stores that object. Now an actual student object should exist in memory. So if we have to create multiple object, once again, if we have to create multiple objects, let's create more. Let's create more. S1 student, S2 student, then S3 student. So now we have three different objects. All of them are created from the same class. Each object is independent. Okay. So understanding memory. So understanding memory. Okay. So even though all three objects come from the same blueprint, Python creates separate memory for each object. Think about three houses built from the same design. The design is identical, but each house is separate. So objects work the same way. So naming convention, convention by convention, class names are written using Pascal case. Example, one second. Example, class bank account pass class mobile phone pass. So object name are usually written in lowercase. So example, student 1 is equal to student student 2 is equal to student. So following these conventions makes your code easier to read. So next how practice question. One practice question ahead. Class car pass. Now if we create two objects like car 1 is equal to car 2 is equal to car. So if we have run the program, so no output will appear. That's perfectly normal because the objects currently don't contain any data or behavior. So some common mistakes that beginner can make, that writing student is equal to class. This is in one second. Student is equal to class. So this is invalid syntax. What we have to write? We have to write this class student. Okay. So mistake number two, that thinking that creating a class automatically create objects. So it's no, that but objects are created only when you write student. Okay. So next mistake is using lowercase class names instead of class student. We have to use this class student. Okay. Now we have some Viva questions. So first one is, what is an object-oriented programming? So answer is, object-oriented programming is the programming paradigm that represents real-world entities using classes and objects. So what is a class? A class is a blueprint used to create objects. So what is an object? An object is an instance of the class. Can we create multiple objects from one class? So answer is yes. A single class can create any number of objects. So next we are going to do constructor. Okay. So if we in the previous topic we created our first class and objects. Right now our objects are empty. So if you create three student objects, they don't contain any information. But in real life, every student has name, age, roll number, marks. So how do we store all the information inside an object? So for that, Python provides constructor and attributes. Let's understand them. So first one is constructor. So whenever an object is created, sometimes we want to initialize it with some data immediately. So Python provides a special method for this. It is called the constructor. The constructor name is always underscore underscore NIT, NIT, IIT and underscore underscore then bracket. Okay. So this method is automatically executed whenever a new object is created. So our first constructor is def sorry plus student def INIT SISULF then print student object created. That's one is equal to student and output will be student object created. Okay. So if you notice this, we never wrote s1 dot underscore NIIT and underscore. Okay. So still the constructor executed. But why? Because Python automatically calls it during object creation. So why constructor? Imagine you build buying a brand new mobile phone. As soon as you switch it on, it already has language static settings, date and time, system applications. No, nobody configures this manually every single time. Okay. Similarly, a constructor prepares an object with initial values. Okay. So now we have constructor and parameters. Instead of printing a message, let's pass information self name then print name s1 equals student Ayush then. So now if we run this, so it will show Ayush. So now the constructor receives data by creating the object. So now understand self. One second. Yes. So now let's discuss the most confusing keyword for beginners. That keyword is self. Okay. So actually, self simply refers to the current object. Whenever an object calls a method, Python automatically passes that object as the first argument. For example, S1 is equal to student Ayush. So initially Python works like this: student, one second, student dot INIT S1 Ayush. So what here will be SELF is equal to S1. If any other object is created, then it will be S2 is equal to student Priya. Okay. And internally we have to write student dot INIT So now what we will write then, self is equal to s2. Okay, so self always point to the object that is currently being created or used. So now we have instance of attributes. So now let's store the student's name. Okay, that is class student def init, then self name, then self, once again, self dot name is equal to name. Then we have to create an object. S1 is equal to student Ayush, S2 is equal to student Priya. Okay, so print, then print S1 dot name, then print S2 dot name. Okay, so output will be what? Ayush and Priya. So if you notice that Ayush belongs only to S1, then and Priya only belongs to S2. So every object has its own copy of these variables. So these variables are called instance attributes. Okay. So next we are on to multiple instance of attributes. Okay. So let's store more information. Class student def int as self name, then age and marks. Okay, age, marks. So self dot name is equal to name, self dot age is equal to age, self dot marks is equal to marks. Okay, so S1 student Ayush, then 20, 95, Priya 90, 85, then print S1 dot age, print S1 dot marks. So now it will be Ayush 2095. Okay, so now our object stored complete information about a student. So next we are class attribute. Okay, so now suppose every student studies in the same college. Instead of storing the college name separately inside every object, we can store it once inside the class. Example, class student and college is equal to ABC college, then def int self name, then self dot name is equal to name, then s1 is equal to student, then Ayush, then s2 is equal to student area. Okay, so if we have to print s1 dot college, s2 dot college. Okay, so Next output will be ABC college, ABC college. Okay. So both objects use the same value. This variable belong to the class, therefore it is called a class attribute. Okay. So next, difference between instance and class attribute. So in class attribute, it belongs to class. Then instance attribute, it belongs to object. And in class attribute, it shared by all objects. In instance attribute, it different for every object. And in class attribute, it has one copy, and in instance attribute, it's separate copy for each object. Okay. So now I will tell you the real life example based on this. That think about a school. Every student has a different name, roll number, marks. These are instance attributes. But school name, city, principal name remain the same for every student. These are similar to class attributes. Okay. So some common mistake that beginner can make, that is mistake number one, writing name is equal to name, but we have to write self dot name is equal to name. Okay. So mistake number two, forget self, and wrong def int and name only. We have to write self also. Okay. So mistake number three, that is trying to change a class attribute when you actually wanted an instance attribute. Okay, so always ask this: is this value common for every object or unique for each object? Okay, so you have to ask this. Okay, so now we have to do some Viva questions based on this. That is, what is a constructor? A constructor is a special method named I underscore double underscore I and it, then double underscore. Okay, so and then bracket. Okay, that runs automatically when an object is created. Okay, so what is self? Self returns to the, so self refers to the current object. Okay, so what is an instance attribute? So an attribute that belongs to an individual object. So what is the class attribute? So an attribute that is shared by all objects of a class. Okay, so next we are going to do methods. Okay, so now our object have data. The next question is, how can an object perform action? For example, a student should be able to display details, calculate average marks. A car should be able to start, stop. A bank account should deposit money, withdraw money. So these actions are performed using methods. So let's understand them. So what is a method? A method is simply a function written inside a class. So unlike normal functions, methods are used to perform operations related to an object. Okay, so let's create our first method, that is example number one, that is class student, then def display cell print welcome to Python. Okay, so next create, will create an object s1 is equal to student, then s1 dot display, then output will be welcome to Python. Okay, so here display belong to the student class. We call it using an object s1 dot display. Okay, so method using object data. So let's make this more useful. Once again, okay, so display init, then self name, then self dot name is equal to name, student name self dot name. So if you want to create an object, then s1 is equal to student Ayush, then s1 dot display, then output will be student name, sorry, student name spelling, then student name Ayush. Okay, so now create another object. S2 is equal to student Priya. So S2 dot display. Okay, so our output will be student name Priya. Okay, so if you notice something, the same method work for different objects because each object stored different values. Okay, so now I will tell you the real life example based on this. That is, think about a TV. Every TV has a different brand and size. So every TV can perform actions like turn on, turn off, increase volume. Similarly, object contain data and method perform actions using that data. Okay. So now we have practice questions that we can do. Okay. And so first practice question is uh, student average. Okay, so now let's understand practical question. So problem statement it is. Okay, so create a student class first of all, then store name, physics marks, chemistry marks, then math marks, then calculate the average marks. Okay, first we will do class student dash chemistry math, then self dot math is equal to name is equal to name. Self dot phy is equal to phy. Self dot chem is equal to chem. Linear average. Self then Self dot phi plus self dot them plus self dot th. So then divide by 3, then print average, then average. Print average 20, 50, then 35, then S1 dot average. So if we run the output, then output will be average 8.5. Okay, 85.0. Okay. So next, so the construction store all subject marks. The average method perform the calculation. This is the main advantage of OOP. So data and operation stay together inside one class. Okay. So now we improve the program. So let's display complete student information. Class student, uh, def INIT self named PHY chemistry math and self dot names to or Steve the def average self, sorry, display self, then print name self dot name print physics self dot PHY, then print chemistry, then print branch, branch, self dot math, then we will do what DEF average self, then average self dot phy plus self dot chem plus self dot math. Then divide by 3. Then we will do print print average. Then S1 is equal to student Ayush 90 80 85. Then S1 dot display S2 dot display. Then we will see once again. S1 dot average. Then we will see the output. And name Ayush, physics 90, chemistry 80, math 85, average 85. Okay. So improving the program, we improve the program. Okay. So next we have, now our class look much more organized. Instead of writing calculations outside, everything stayed inside the student class. Okay. So now we do studying method. Okay. Sometimes we need a method that doesn't work with object data. For example, suppose we simply want to display welcome to ABC College. Okay. This message is the same for everyone. In such cases, Python provides static method. Syntax static static method. So example is class student, then static method, then def college, then print welcome to ABC College. Okay, so now we will run this program. So output is, one second. So one thing we also should do, that we have to run the we call student dot college. Okay, so one second. So now the answer is welcome to ABC College output. Okay, so if you notice that no object was created till the method executed. Okay, so because static method belong to the class. Okay, another example. Output is 35. Okay, so static methods are commonly used for utility tasks that don't require object specific data. Okay, so difference between, okay, so difference between instance method and static method. Okay, so in instance method, it calling using object, and in static method, it calling using class. In instance, it works with object data, and in static, it doesn't use object data. Okay, in instance, it uses self, and in static, it doesn't use self. So some mistakes that common beginner can make, that is mistake number one, writing an instance method without self. Okay, so that is like def display. So it is wrong, and if you have to correct this, you have to write like this, okay, and you have to write commas or a colon also. So it is correct. Next, forgetting the decorated before a static method. Like if you write this def college, so and this, so it is wrong. If you want to correct this, then now you have to include this. Okay, so this is correct one. Okay, so next, so mistake number three is trying to access object attributes inside a static method. Static method don't automatically receive the current object. Okay, so some Viva questions are there, that is, what is a method? So a method is a function defined inside a class. And what is an instance method? So a method that works with object data. So what is a static method? A method that belongs to class and doesn't require an object. So which decorator is used to create a static method? So answer is static method, static method. Okay. So next we are going to talk about abstraction. Okay. So until now our classes can store information, perform operations using methods. Now let's learn the concept that makes software more secure and easier to use. These concepts are abstraction and encapsulation. Okay, these are used in almost every professional software project. So let's start with abstraction. So what is abstraction? Imagine you are driving a car. You simply insert the key, press the start button, and drive the car. But do you know exactly how the engine starts, how fuel reaches the engine, how thousands of mechanical parts work together? So you don't know, okay? And you don't need to know. So you only use the required functionality. The complete implementation remain hidden. This concept is called abstraction. Example of ATM, like let's take the example like for ATM. Suppose you visit an ATM, you insert your card, enter your PIN, choose withdraw, collect your cash. Behind scenes, many operations happen: PIN verification, server communication, balance checking, transaction recording. So you never see these processes. You only interact with the options you need. Okay, so that is abstraction. Next is mobile application example. Whenever you open the camera application, you simply press the capture button. You don't know image processing, AI enhancement, compression algorithm, file encoding. So everything is hidden. Only the required feature is visible again. This is abstraction. Okay. So in Python abstraction is in programming, object-oriented programming. Abstraction means hiding unnecessary implementation details while exposing only the required functionality to the user. So this makes software easy to use, easy to understand, easy to maintain. So I'll repeat the definition there, that is hiding unnecessary implementation details while exposing only the required functionality to the user. Okay. So I have example for this, that is class car dev start self then print car started. Okay, so next car is equal to car then car dot start. So output will be what? Car started. So here the user simply call car dot start. Okay, so the user doesn't need to know how the engine start internally. So that internal complexity remain hidden. Okay, so what is the benefit of abstraction? So what is the benefit of abstraction? So it helps us hide complexity, improve readability, reduce confusion, make application easier to maintain. This is why every modern software system uses abstraction. Okay. So next is encapsulation. Okay. So now let's move to the second concept, that is encapsulation, that is combining data and the method that operate on that data into a single unit, which is a class. It also helps protect important data from being modified directly. Okay. So I'll repeat the definition, that is combining data and method that operate on the data into a single unit. Okay. So which is a class. I'll give you a real life example based on this. That is, think about a medicine capsule. Okay, so inside one capsule, different medicines are packed together. Okay, you don't see each ingredient separately. Everything is enclosed in one unit. Similarly, a class combines attributes and methods. Attributes, that is data, and methods, that is function. Okay, so this is called encapsulation. So next we are going to do a practical class, then student def init self name self dot name is equal to name, then def display, then print self dot name. So if we notice, one second. Self. So if you notice that both self.name and display are inside the same class, data and behavior are left together. Okay, so that is encapsulation. If we run this, so next is public attribute. Okay, public attribute. So by default, every attribute in Python is public. Example, name, name S1 equals to then Ayush, then print S1 dot name. Then output, what is output? Ayush. Okay. So anyone can access this variable. So next is private attribute. Private attribute. So sometimes important information should not be accessed directly. Okay. So for example, bank balance, ATM pin, password, salary. Python allow us to create private attributes. Okay. We simply use two underscores under double underscore and balance. That is okay. So next we have practice example based on this bank def self self dot underscore balance 50 5 April. Now if we create an object on an account, so now if we try to print account dot balance, then what will be output? So output will be attribute error. Okay. So Python prevents direct access. Okay. So next is accessing private data properly. Instead of accessing the variable directly, created method. Okay. So next, balance per 55,000 account is equal to show balance self print self dot underscore underscore balance. Then if we create object account bank, then account dot show balance. Okay. And then output will be what? Output will be 5,000. Okay. So now the balance can be viewed only through the provided method. So this is the practical use of encapsulation. So now why encapsulation is important. So suppose balance were public, anyone could write account and dot balance is equal to 1 lakh or 1 crore something. So and change the account balance directly. That would be dangerous. Okay. So encapsulation protects sensitive data by controlling how it is accessed. So now difference between difference between abstraction and encapsulation. So, in abstraction, it hides implementation details, and in encapsulation, it wraps data and method together. In abstraction, it focuses on simplicity, and encapsulation, it focuses on data protection. Okay, so some mistakes that beginners can make, that is mistake number one, using a single underscore balance. Okay, you have to use double underscore, that is like this, double underscore balance. Okay, and assuming it is fully private. In Python, trolley name mangling happens with double underscore balance. Okay, and two leading underscore. So it's and second mistake, that trying to access private attributes directly. So like print account dot balance. So it is wrong. Correct will be what? Account count dot show balance. Okay. So next mistake is, that the third mistake. Okay, thinking abstraction and encapsulation are the same. So they are related but different. Okay, abstraction hides complexity and encapsulation protects and organizes data. Okay, so now we have some Viva questions, that is, what is abstraction? So abstraction is the process of hiding implementation details while exposing only the required functionality. So next is, what is encapsulation? So it is the process of wrapping data and methods into a single class while protecting important data. So now, how do you create a private attribute in Python? So self dot double underscore balance. Why is encapsulation important? So answer is, it protects sensitive data and provides control access to it. Okay. So now we will do some practice questions. Okay. So first question is, create an employee class that takes the employee's name, department, and salary using a constructor, and create a method to display all the details. So class employee def INIT self name department salary, then self dot name is equal to name self dot department is equal to department self dot salary is equal to salary, then def display details self print name self dot name, then print department, self dot department, then print salary, then here A1 is equal to employee, then common IT, then 50,000, then E1 dot display details. So here employee is the class and E1 is its object. Okay. The INIT method is the constructor. It automatically executes when we create an object. Okay. So the self parameter refers to the connect object and so self.name, self.department and self.salary. Store data specific to the employee. Okay. The display detail method accesses this instance attributes and prints them. Okay. So so it is output of this question. Okay. So now one second. So now we will do our second question, that is count the number of objects created. Okay. So create a student class that keep the track of the total number of student objects created. So class student count is equal to 0 def init self name self dot name name is equal to name, then student dot count is equal to class is equal to 1, then s1 is equal to student, then common slash 2 is equal to student, then travel, then s3 is equal to student prior, then print total students, then student dot count. Okay. So here count is the class attribute because it belongs to the class rather than one particular object. Okay. So every time when a student object is created, the constructor runs and increases student dot count by 1. Okay. So after creating these three objects, the output will be total students is equal to 3. Okay. So this is a good example of the difference between class attribute and instance attribute. Okay. So next question R will be create a calculator class. Create a calculator class with method for addition, subtraction, multiplication, and division. Okay. So now we are going to do our third question. Create calculator F and self A B return A B F subtract self A B then return A minus B then def multiply self A B then return A multiply B then def divide self A B then return A B then C is equal to calculator then print C dot add 10 5 then print C dot subtract 10 5 then print C dot multiply 10 comma 5 then print C dot divide 10 comma 5 then if we run this then we have 10 15 5 50 and 2.0 okay. So the calculator class contains four methods. We create an object C and use that object to call the method okay. For example, C dot add 10 5. Call the add method for object C. This demonstrate how method are function that belong to objects okay. So next question is static method for checking even or odd. So the question is create a number class with the static method that check whether the number is even or odd. So now class number then at the rate static method def check even odd and if n percentage 2 is equal to 0 return even return odd then print number dot check even odd 20 then print check in out. Okay. So the output is even and odd. Okay. So we use static method because the method doesn't need any object specific data. So if you notice that we don't use self inserter method, we can directly call it using the class name number.check even not 20. Okay, so the number is divisible by 2, it returns even, otherwise it returns odd. So next question, that is the last question, encapsulation secure amount. Okay, create a bank account class with a private balance provide method to deposit money, withdraw money and check the balance. Okay, so create bank account debt IN90 self balance self dot underscore balance is equal to balance the deposit self amount then self dot underscore balance plus is equal to amount then the withdraw self amount if amount less than is equal to self dot double underscore balance then self dot double underscore balance minus is equal to amount then else print insufficient balance. Next, the check school balance self then print balance self dot double underscore balance then account is equal to balance bank account Punjab then account dot deposit 2000 account balance. Okay, so the balance attribute is private because it starts with double underscore. Okay, so this means we should not directly manipulate the balance from outside the class. Okay, instead we provide controlled methods such as deposit, withdraw, and check balance. So this concept is called encapsulation, keeping data and method that operate on the data together inside the class while controlling how the data is expressed. Okay, so if we see the output, so balance is 6,000. Okay, so now we are over with this topic and we are over with this entire course. So thank you very much for your support and keep follow this channel and keep liking videos and views. Okay, so thank you very much